Hello, Assembler students. This is the second video in the series of going through that Lab 0 example. Previous video, we got as far as loading up the program, going through its anatomy, showing you continue stepping through it right now until we get to the end, and then that'll be it will contain everything you need to know in order to do your first programming homework. So all the elements of assembler which are needed for the first programming homework, almost the exact same instructions with slight differences. Most of them are in this demo. So where we done line 22 here, and line 22 was putting the letter A into memory where the ESI register contained the address, and that you'll recall was this 61 up here, because that's BL register contains a hex 61. That's our hex 61, and 61 is an ASCII A. Next we do something which is you do in assembler and you don't do in high-level languages. Inc over here is increment. It means to count by one, and I'm going to point you right now at the ESI register. One moment. Here's your ESI register. That's the address on the street, and the first house was the house we just put the A in and the 61 in, and this increment is just going to say go to the next house number. So let's see that. And now, if you'll take a look, you'll see that's increased by 1. So this number here is the address of this byte over here. Or if you want to go up to the top of our data section, it's going to be up there. So the next thing we're going to do is we're going to increment the BL register. You'll remember the BL register was this one byte over here. That was a hex 61. Incrementing it's going to be a hex 62, which is not surprisingly going to be an ASCII B. So let's do that right now. Over here we now have hex 62. The next thing we're going to do is decrement, count down, ECX. ECX is going to be a loop counter. You'll recall from not very many instructions ago that ECX had a 5 in it. So counting it down should make a 4. And indeed, now we have a 4. J and Z requires a little bit of explanation. Again, this is a little bit of review from what I did in the Glassboard lecture. But the idea is that the arithmetic instructions and similar instructions, the ones that change data, leave a result hanging around in some place for the flags register. It's called the flags register. And we have flags to say whether or not the result of that previous arithmetic we did was 0, or the result was positive, or the result was negative, or a couple of other possibilities there, believe it or not. They're not all mutually exclusive. It can be positive and some other things. So the basic notion, if we want to do something like an if statement, is do some arithmetic. Like if I want to find out if A is greater than B, I can compute A minus B and then see was the result of that operation negative or not, or positive, or zero. So that's how we do if statements in assembler. It isn't one statement. The if has been broken down into a couple of different pieces, one of which is do this kind of arithmetic, and the other is go look and see what kind of results we had. Not numerical results, but these flag bits results that are qualitatively telling us something about it. So JNZ means jump if not 0, and the result of that decrement was a 4, not 0. And then over here is next. Next is a label. Just like out message was a label and ch out was a label. A label is what? It's a name we attach to a spot in memory, an address. And so our program counter is going to, instead of marching further down the page, we'll just go back to where that label is. Wherever that label is, that number, that address in memory, that's where it's going to start doing code again. So I'm going to do that right now, and we'll step through the next few because they are, of course, repeats, because why? This is a loop, right? All right, you will notice that BL, which was incremented, now had a letter B in it, hex 62. We printed out the B and the 62. We are now about to execute line 22, that move, and BL, the hex 62, is going to go where? Well, it's going to go into memory. That's what the brackets mean. And where in memory? Well, ESI contains the address. Remember that we have the addresses of the house going down Data Street there. So we now have the address of the next house. So imagine we're like a delivery guy and a delivery person going down the street. And we have a list of, we got an address. What's the next address, house we're going to? Well, a little while ago, we were at the house at the address in ESI was at this house over here. And now we're at the address. We incremented the address. The address is telling the delivery guy to go to the next house down the street. Where are we going to deliver what? We're going to deliver a letter B, hex 62. All right. Okay. There we go. Let's show you that. So ESI is now a slightly bigger number than it was before. And here the hex 62 is going to go into the next byte, the next house down the street, using the next address, which is in ESI. So let's see that happen. You'll see that 0 change to a 62. And indeed, that's what happened. Okay, right there. Now we're going to increment ESI again, and that'll be the next address. So ESI right now is, some big hex number, but right now it's got 6 in it, and then the next address down the street will be blah blah blah, ending in 7. Okay, there's our 7. And of course, BL contains our character, which was a hex 62. It's now going up to be a hex 63 in that byte. There is our hex 63 right there. And then we're going to decrement ECX, which had a 4. That's going to become a 3. And now we're going to see if it was 0. No, it was 3. And here we are up at the top of the loop where we print out our character, which our character just became 63, or C rather. And we're about to what? We're about to put BL into memory, and ESI is the next address. So ESI now is the next address, and this address is going to point to the next byte, and the next byte we just printed out is a hex 63. Here's the hex 63. So that will go into the next byte of memory right there. Okay? So there we have our 63 in the next byte of memory. So this is A, B, C in memory before it was 0, 0, 0. We're going to increment the address to point to the 8, the address ending in 8. We're going to increment the character to get a D, hex 64. We're going to count down from 3 down to 2. 2 is at 0. Now we're back to the top of the loop, where we print out the D which we just created, which was a hex 64 like that. Over here. Okay, we only got one more letter to go. That's E. So I will step through that. First we have to put the D in memory over here. Then we have to increment to the next address, which will be 9. Then we're going to increment to the next letter over here in BL, which will be E, 65. We're going to decrement the counter down to 1. 1 is not 0. So we're going to print out our new E, 65. E is going to go into that next spot in memory. Right there. And what? Well, we'll point to the next address. We'll make an F. We'll decrement ECX. So there's our F. There's our next address. ECX is 1. We decrement it. This time we have 0. So we're not going to keep looping. So at this point, I'm going to go back and show you a little bit with the data. One moment. So looking at our data section, which we're displaying here in the debugger, here's our C, HAR, the 63, the 68 in hex, all the way to the left bracket, which is the 5B. Immediately following that was a 0, which now contains an A, and then some more zeros contain B, C, D, E. Then we had a right bracket, which is a 5D over here. And then the next thing in memory was a 0, which was over here. So this thing is a bunch of successive bytes in memory that contain ASCII characters. They're on several different lines of our program, but in memory they're all one after the other. And the last one is a 0. So if you've taken C, you know that strings are a bunch of characters in memory ending with a 0. And that's what we have. We have here the equivalent of a C string. And what we're going to end up doing is printing it out. But the important point here, important points to notice here are that we got this string, that we did it by just plugging things into different addresses in memory, and we did arithmetic on numbers in order to get new numbers, which then actually turn out to be new characters. So one moment. Okay, having produced this long string, which has char equals and then A, B, C, D, E, we can now step through the code, which has one of those magic I/O things, and look what comes out. There's our characters. Now at this point, we're done. This thing's a subroutine. It will return. And that's it. So coming up, how to do the homework.